Alright, in today's lesson here, we're going to take a look at finding the equation from a table of values, a linear equation here. So the focus here is you're given a bunch of tables, relations here, and you want to decide, is this a linear relation? And if it is a linear relation, you'd like to find the equation y equals mx plus b. So just to remind you here, any linear equation you have, if it is in fact linear, can be represented as y equals mx plus b, where our m value is our rate of change, also known as our slope, and the b value is our y-intercept, also known as our initial value. So let's take a look at our first table here. So I'm given this table, I want to know, first of all, I want to know, is this linear? So what I have to do is I have to go ahead and calculate what's called the first differences. So your first differences are calculated by taking the bottom entry minus the top entry. So in this case here, 2 minus 0 is 2, 4 minus 2 is 2, 6 minus 4 is 2, and the last entry is 2 as well. So I can see here that this relation, whatever it may be, is increasing by the same amount each time. Now we have to check the left-hand side and see what's going on the left-hand side. Also calculate the first differences on the left, in which case we increased by 4, we increased by 4, we increased by 4, and we also increased by 4. So our observation here is now, as I take a step each time of a jump of 4, I'm going up by the exact same amount each time. So because of that, this relationship was said to be linear. So this is a linear relationship. And because it's a linear relationship, I now know I can express this relationship in the form y equals mx plus b. So we therefore have to find our rate of change, also known as our slope, and our initial value. Well, your rate of change, also known as your slope here, is going to be the change in your y's over the change in your x's. So if you take a look here, I'm changing in my y's by a factor of 2 every time, and I'm changing in my x's by a factor of 4, so this becomes a half. Keep in mind that your slope is the number of... Keep in mind that your slope is the change in your y for 1 unit change in your x. What this means is, for every step I take over in my x-axis here, my y-coordinate, my y value goes up by a half. Right, you can see here we've taken 4 steps, and if you take a half plus a half plus a half plus a half, that is exactly equal to 2. So your rate of change, or your slope, is for 1 unit of change. Now your initial value happens when x is 0. So if you take a look at this graph here, you'll notice here we're decreasing by 4. As I move up this graph, decreasing by 4, I want to get a value when x is 0. So when x is 0 here, I would only have to take 1 step back to take me to 0, in which case I can do that. I can take 1 step up to get my another entry in this table that was not given to us. It gives me my 0, which is what I want for my initial value. I need the corresponding y value. We can see that your rate of change here is a half every step. So therefore this would be minus a half in this entry here. So your initial value here, also known as your b value, is going to be minus a half. So now we just put this all together. The equation is y equals m, which is 1/2 x, plus b, and my b value is minus a half. So typically people will write it and express this without the plus minus symbol. So we would just finish this up and have y equals 1/2 x minus a half. And that becomes our linear relationship to represent this table of values. Let's take a look at another. So same thing here. I can quickly see here my change in my y's are 1 apiece. This time my change in my x's are 5 every single time. So right away this relationship is also linear. And my equation, before I find my equation, I'll have to find my slope. And my slope here is going to be the change in my y's, which is 1 divided by the change in my x's, which is 5. My initial value here is actually given to me right here. It happens when x is 0. Your initial value is always when x is 0, in which case my corresponding y value, i.e. my initial value, is 2. Get that right there. So my equation is y equals mx plus your b value. So y equals 1/2 x plus 2. All right, let's take a look at the next one. So for this one here, you can see we're dropping by 10 this time, every single time here. And on the left-hand side, we are increasing by 2, increasing by 2, increasing by 2 every single time. So once again, this is also a linear relationship. And the slope of this line is going to be the change in my y over the change in my x. This time it's -5. So that becomes my slope. As I continue this pattern here, and you're going up, if I decrease by 2 again, I'll get 0, which is what I want. And you can see this is increasing by 10 if I go from bottom to top. So this will be 110. So my b value here ends up being 110. The equation is y equals -5x plus 110. Let's take a look at number 4. So for number 4 here, you can see I am decreasing by 1. Now I'm increasing by 3, decreasing by 2, and decreasing by 2. So you can see the numbers are all over the place here. We should check the left just to make sure. And you can see if you check the left, these are actually consistent, increasing by 1 each time. So I take a step over, I go down 1, then I take a step over, I go up 3. Right away, this is a nonlinear relationship. And this is a nonlinear relationship, and therefore there is no equation y equals mx plus b. Let's take a look at number 5. So for number 5 here, you can see we're increasing by 10, increasing by 10, 10, 10. And on the left, also increasing by 10 every time. And this one's a quick one. The rate of change here is 10 over 10, which is 1. And my initial value, i.e. my b value here, is 0. So this is, we have ourselves a linear relationship, and the equation is y equals, you can put 1x plus 0, or a lot of times you just abbreviate this as being y equals x. But 1x plus 0 is right as well, but simplified, typically written as y equals x. Let's take a look at number 6. Number 6, the same idea here. We're decreasing by 10, decreasing by 10, decreasing by 10, decreasing by 10. In the x's, we're increasing by 10, increasing by 10, increasing by 10, increasing by 10. So right away, also a linear relationship. My rate of change here, or my slope, is change in my y over change in my x, which is -1. My b value here, again, you're grabbing initial value, so you want to grab when x is 0, in which case my initial value is 40. Putting this together here, we have y equals -x plus 40. And I have my equation of my line. Number 7 here. Now number 7, if you take a look at number 7, you can see the change in my y's are 0. And the change in my x's, I won't write them out, but they're 1 apiece. So you go through all the same steps. Still, this is linear. It follows our definition of linear. It's, changing by the same amount each unit step over. So the slope here is going to be 0 over 1, which is 0. And the y-intercept happens when x is 0. If I let x be 0 here, we follow the pattern. You have 5, 4, 3, 2, 1. You're going to have a coordinate of 0. And then your corresponding y value here will therefore also be 2. Right? It's outputting a 2 every single time. So my y-intercept is 2. Putting this together, you have y equals 0x plus 2. But 0 times anything is just 0. So this simplifies to become y equals 2. And what that means is no matter what x value you choose, it's going to output a y value of 2. We can see here for number 8, you have the exact same scenario. The change here in my y's are always 0. And you can see here the change in my x's are 1s. So going through this again, you'll end up going through the math. You'll end up getting y equals -2 this time for this relationship here. We end up getting my slope here, my m value, is changing my y's over change my x's. And right away we find that's undefined. So this is undefined, and what that means is the slope does not exist. And we'll go into more detail graphically what that means, but if the slope doesn't exist here, what's going on for this equation is no matter what y value you choose, I'm going to be outputting an x value of 4 this time. So the concept is kind of flipped. This will create a vertical line, and we'll discuss that a bit later. But this is the general idea is now no matter what y value I'm choosing, I have here x values outputting 4. Whereas in the previous question, you can see these previous 2 questions, no matter what x value I choose, I have a constant y value, a constant y value, and that creates the opposite. All right, let's take a look at number 9. So for number 9 here, you have your change in your y. So bottom minus top, this is -1/2, -1/2 minus 0, -1/2. This would be -1/2 minus -1, which will also be -1/2. And lastly, negative 3/2 minus negative 1 is also minus 1/2. So again, I'm taking steps down by a factor of minus 1/2 every time. I'm taking steps over by a factor of minus 10 every time, decreasing by 10 every single time. So if I go calculate my slope here, for this one, my rate of change, or my slope, is going to be the change in my y over change in my x, in which case my slope here is going to be negative 1/2 divided by negative 10. That's going to be negative 1/2 divided by negative 10 over 1 is minus 1/2 times 1 over negative 10. You end up getting 1 over 20. So the slope for this line is 1 over 20, so the equation becomes 1 over 20x. Now I need to find my b value, and you take a look here. You look at it, your b value is sitting right here. When x is 0, my y value is 0, so my b value is also 0 here. So again, you can put 1/2, 1 over 20x plus 0, or just the 1 over 20, and we are done. All right, let's take a look at 10 and 11. So for number 10 here, same idea. We want to calculate the change in the y's. This will be equal to positive 1/4. Positive 1/4. Now 5/4, 3/2. Again, if you want, off to the side of your page, you can take 3/2 minus 5/4. Get yourself a common denominator here, and you end up getting 1/4 as well. So the change in my y is positive 1/4, and lastly, this will also be positive 1/4. So we have a constant change in my y, and you can quickly see here we're changing in the x's by 1. So the slope of this line is going to be 1/4 divided by 1, which is obviously just 1/4. To find my initial value, again, you have to find this pattern. And you can see here I'm decreasing by 1 every time, so I'm going to go up here, give me a 0. If you take 3/4 minus 1/4, you can get 2 over 4. Also reduces to become 1/2. So this, your b value for this question is 1/2. Putting this together for our linear relationship, this is y equals 1/4 x plus 1/2. And this question's done. All right, let's take a look at the last question here. So if you take a look here, we're increasing by 10 every single time. So looking like it's linear. However, right away I increased by 2 and then I increased by 1. I don't even have to continue. I know right away this is nonlinear because for 2 steps over I went up by 10. Then for 1 step over I also went up by 10. So you do not have a linear relationship. For this very last one here, this is nonlinear. And if you do not have a linear relationship, then you cannot express this in the form y equals mx plus b. Okay, that about covers it for finding the equation of a line given table of values. You can see all the differences here. Feel free to study this. Thank you.